Hi to everyone, myself Dr. T. Dhananjay Rao, working as assistant professor in the Department of Chemistry. Today I am going to teach about thermoplastics. See, in this video I am going to cover these topics. What is thermoplastics and preparation of polyvinyl chloride and properties and uses of polyvinyl chloride and preparation of nylon 66 and properties and uses of nylon 66. In this video I am going to cover these topics. What is thermoplastic and preparation of polyvinyl chloride and properties and uses of polyvinyl chloride and preparation of nylon 6,6 and properties and uses of its nylon 66. See, thermoplastic. Yesterday video I have discussed about what is thermoplastic and what is thermosetting plastic. Again I am going to teach about thermoplastic. See, what is thermoplastic? The thermoplastic can be softened on heating and hardened on cooling. The thermoplastics can be softened on heating and hardened on cooling. They are generally soluble in organic solvents. Once cooled, they show no changes in chemical properties. Once if the cool thermoplastic, then there is no changes in chemical properties. Meaning they can be remelted and reused several times. The thermoplastics can be remelted and reused several times. What is thermoplastic? The thermoplastics can be softened on heating, hardened on cooling. They are generally soluble in organic solvents. Once cooled, they show no chemical changes in its chemical properties, meaning they can be remelted and reused several times. Example for thermoplastics are polyethylene and polyvinyl chloride. The examples for thermoplastics are polyethylene and polyvinyl chloride. The thermoplastics are prepared by addition polymerization. The thermoplastics are prepared by the simple addition polymerization. They are straight chain or slightly branched polymers. The thermoplastics are straight chain or slightly branched polymers, and various chains are held together by weak van der Waals forces of attraction. The two chains in a thermoplastics are held together by weak van der Waals forces. They are straight and slightly branched polymers, and various chains are present in the thermoplastics are held together by van der Waals forces of attraction. See, these are the example for thermoplastics. See, the first one is polyvinyl chloride. Polyvinyl chloride is example for the thermoplastic. See, in this, the preparation and properties and uses of polyvinyl chloride we are going to learn. How we can prepare polyvinyl chloride polymer and what is the properties of polyvinyl chloride and application of polyvinyl chloride. The polyvinyl chloride is example for the thermoplastic. See, the preparation. How we can prepare the polyvinyl chloride. See, the step 1. The vinyl chloride is prepared by treating acetylene with hydrogen chloride. How we can prepare vinyl chloride? The vinyl chloride is the monomer for the synthesis of polyvinyl chloride. Then how we can prepare the vinyl chloride? First we have to prepare vinyl chloride. From vinyl chloride we have to synthesis polyvinyl chloride. See how we can prepare in step 1 vinyl chloride. The vinyl chloride will be prepared by using acetylene gas and hydrogen chloride. Hydrogen chloride and acetylene gas. Acetylene gas is treated with hydrochloric acid or HCl at 60 to 80 degrees centigrade in the presence of metal chloride as catalyst. Any metal chloride, metal oxide, if you use the catalyst at temperature, at what temperature? 60 to 80 degrees centigrade. If you use the temperature, the acetylene gas, HC=CH means that is acetylene gas reacts with HCl, hydrochloric acid, in presence of metal chloride or metal oxide, any metal chloride or any metal oxide, okay, at temperature 60 to 80 degrees centigrade, okay. In this condition, the acetylene reacts with hydrochloric acid, it forms vinyl chloride. The product will be vinyl chloride. See how we can prepare vinyl chloride? The vinyl chloride prepared from the acetylene gas reacts with hydrochloric acid in presence of any metal chloride or metal oxide at temperature 60 to 80 degree centigrade. If you maintain this chemical atmosphere, then we can prepare the vinyl chloride from the acetylene and HCl solutions. Okay, this is the preparation of vinyl chloride. Then next step, see, then the step 2, the polyvinyl chloride is produced by heating. The polyvinyl chloride is produced by heating vinyl chloride in presence of benzyl peroxide or H2O2 under pressure. How we can prepare polyvinyl chloride from vinyl chloride? In first step we have prepared vinyl chloride. Okay, from vinyl chloride we have to prepare polyvinyl chloride. How we can prepare polyvinyl chloride? See, the vinyl chloride in presence of benzoyl peroxide H2O2. What is the benzoyl peroxide? The benzoyl peroxide formula is benzene. Okay, benzene OOH. This is benzoyl peroxide. This is the structure of benzoyl peroxide. And what is the formula for H2O2? H2O2. HOOH. This is the structure of H2O2. The vinyl chloride in presence of benzoyl peroxide. Okay, benzoyl peroxide or peroxide, hydrogen peroxide. Okay, it will undergo polymerization at 30 to 80 degrees centigrade. It forms polyvinyl chloride. It forms polyvinyl chloride. In the step 1, what we have prepared? In step 1, we have prepared vinyl chloride by using acetylene gas in presence of hydrochloric acid. The catalyst is metal chloride and metal oxide. Any metal chloride or metal oxide. Temperature 60 to 80 degrees centigrade. These two reactant gives the product vinyl chloride. Okay, that these two, acetylene gas and hydrochloric acid, in presence of catalyst metal chloride or metal oxide in presence of temperature 60 to 80 degrees centigrade, it produce vinyl chloride. It is a monomer. Okay, by using this monomer, we have to prepare polyvinyl chloride. See, the monomer vinyl chloride in the reaction, what is the catalyst? The benzoyl peroxide or the hydrogen peroxide. Any we can use. Okay, anyone we can use. The vinyl chloride in presence of benzoyl peroxide or hydrogen peroxide, it will undergo polymerization at temperature 30 to 80 degrees centigrade. It produces the polymer polyvinyl chloride. The polyvinyl chloride is prepared from the monomer vinyl chloride in the presence of benzoyl peroxide or H2O2 as a catalyst, and the temperature is 30 to 80 degree centigrade. The monomer is vinyl chloride. The product is the polyvinyl chloride. The polyvinyl chloride is example for the thermoplastic. See the properties of the polyvinyl chloride. In the first, we have seen the preparation of the polyvinyl chloride from the vinyl chloride. Vinyl chloride synthesized from the acetylene gas and hydrochloric acid. Okay. In the next step, we are going to study about properties of the polyvinyl chloride. See, the polyvinyl chloride is a very lightweight polymer. The polyvinyl chloride is a very lightweight polymer. The polyvinyl chloride is colorless, odorless and chemically inert powder. The polyvinyl chloride is colorless, odorless and chemically inert powder. The polyvinyl chloride is colorless, odorless and chemically inert powder. It will not undergo any chemical reaction. That is inert powder. It is insoluble in inorganic acids and alkalis. It is insoluble in inorganic acids. Inorganic acids like H2SO4, HCl, like that. Okay. And alkalis. Alkali nothing but basic mediums. Okay. It is this polymer. Polyvinyl chloride is insoluble in inorganic acids and alkalis. Okay. But soluble in hot chlorinated hydrocarbons. Chlorinated hot chlorinated hydrocarbons. The polyvinyl chloride is soluble in the hot chlorinated hydrocarbons. Such as example for hot chlorinated hydrocarbon is ethyl chloride. If you take hot ethyl chloride, the polyvinyl chloride is dissolved in this hot ethyl chloride solution. It undergoes degradation in presence of heat or light. The polyvinyl chloride will undergo degradation in presence of heat or light. Okay, the polyvinyl chloride is undergo degradation in presence of heat or light. The polyvinyl chloride can be made more flexible and softer by adding plasticizers such as phthalate and can be bent as per requirement. The polyvinyl chloride can be made more flexible and softer by adding plasticizers. By addition of plasticizers, the polyvinyl chloride converted into more flexible and softer. Example for the plasticizers are phthalate. Okay, if you add phthalate, the phthalate or plasticizers to the polyvinyl chloride converted into the more flexible and softer. Okay, the polyvinyl chloride products are self-extinguishing due to high chlorine content. The polyvinyl chloride products, okay, the polyvinyl chloride products acts as very self-extinguishing due to high chlorine content. The polyvinyl chloride contain high chlorine content. Okay, the percentage of chlorine is more in the polyvinyl chloride polymer, so it acts as self-extinguishing agents. Okay, the polyvinyl chloride acts as self-extinguishing products. It can withstand extreme climatic conditions. Polyvinyl chloride withstand extreme climatic conditions and shock. And it is free from corrosion, hence it is the preferred method for several outdoor applications. the polyvinyl chloride is free from corrosion. The polyvinyl chloride is free from corrosion. That's why we can prefer this polyvinyl chloride for the several outdoor application. We can prepare several outdoor materials by using this polyvinyl chloride. See, what are the properties of polyvinyl chloride? The polyvinyl chloride is very lightweight polymer, and polyvinyl chloride is colorless, odorless, and chemically inert powder, and it is insoluble in inorganic acids and bases, alkalis, and but soluble in hard chlorinated hydrocarbons like ethyl chloride, and it undergoes degradation in presence of heat and light. Polyvinyl chloride undergo degradation in presence of heat or light. The polyvinyl can be made more flexible by the addition of plasticizers. If you add plasticizer to the polyvinyl chloride, it converts into more flexible. The polyvinyl products are self-extinguishing due to high chlorine content. Due to high chlorine content, the polyvinyl chloride products are self-extinguishing. It can be withstand extreme climatic conditions and shock. It can withstand, the polyvinyl chloride withstand extreme climatic conditions and shock. And polyvinyl chloride is free from corrosion. Hence, it is preferred method for several outdoor applications. We can prepare several outdoor materials by using polyvinyl chloride polymer. See, uses of polyvinyl chloride. See, it is used in the production of pipes, cables, insulations, table covers, and raincoats, etc. By using polyvinyl chloride, we can prepare pipes, cables, insulations, and tables, covers, and raincoats by using this polyvinyl chloride. It is also used for making seats. Which are employed for tank linings and light fittings, refrigerator components, etc. By using polyvinyl chloride, we can prepare tank linings and light fittings and refrigerators components by using polyvinyl chloride. It is used in making sewage pipes and other pipe applications. By using polyvinyl chloride, we can prepare the sewaging pipes. Okay, sewage pipes and the other pipe applications. By using polyvinyl chloride, you can prepare pipes. Okay, used in construction fields for insulation, electric wires or flooring for hospitals. Used in construction fields for insulation on electrical wires or in flooring for hospitals. Using by this PVC, it can be used for flooring for hospitals, schools, homes, and other areas where sterile environment is priority. Where sterile environment is required, by in that case we have to use the polyvinyl chloride as the seeds. Okay, we can cover with this polyvinyl chloride seeds. Okay, by using polyvinyl chloride, we can prepare electrical wires, okay, pipes, and sewage pipes, etc. by using polyvinyl chloride. It is used in various industries like building, electronics, electrical, automotive, medical, and packaging. The polyvinyl chlorides are used in the various industries like building, electronics, electrical, automotive, medical, and packaging. All these industries we can use the polyvinyl chloride. The polyvinyl chloride fabric is used in the manufacture of aprons, shower curtains, and raincoats, jackets, and sports bags. By using polyvinyl chloride, we can prepare the shower aprons, curtains, raincoats, jackets, and sports bags by using polyvinyl chloride. See, this is the uses of the polyvinyl chloride. The next example for thermoplastics are nylon 6,6. How we can prepare the nylon 6,6? See, synthesis of the nylon 6,6. It is obtained by the polymerization of adipic acid with hexamethylene diamine. It is obtained by, how we can prepare nylon 6,6? Nylon 6,6 can be prepared by using polymerization of adipic acid and hexamethylene diamine at high temperature and pressure. It will undergo condensation polymerization. It forms nylon 6,6. What are the monomers present in the nylon 6,6? The adipic acid and hexamethylene diamine. These two are the monomers will undergo condensation polymerization. It will produce the nylon 6,6. What is the product of the nylon 6,6? The adipic acid reacts with hexamethylene diamine. It will undergo condensation polymerization at high temperature and pressure. It will form nylon 6,6. See, the adipic acid formula is CH2, 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 C double bond O, OH, and C double bond O OH. This is the formula for adipic acid. The simple we can write as CH2 4. This functional CH2 are 4 are there, and 2 carboxylic acid functional groups. And what is the hexamethylene diamine? Hexamethylene means 6 hexamethylene groups and 2 amines, that is diamine. The formula for hexamethylene diamine is CH2, 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 1, 2, 3, 4, 5, 6, and NH2 and NH2. This is the structure of hexamethylene diamine. See, the adipic acid reacts with hexamethylene diamine at high temperature and pressure. It will undergo condensation polymerization and forms nylon 6,6. See, the condensation means it will some byproducts will be eliminated. So in this case, the NH2, the H2 from the nitrogen and OH from the carboxylic acid eliminated as water molecule. Okay, what will form? The new amide bond will formation take place. What bond formation takes place? New amide bond. See, initially there is a carboxylic acid bonds are there for the adipic acid functional monomer, and there are amine functional group is there for hexamethylene diamine. These two monomer undergo condensation polymerization. It forms the water elimination takes place, forms new functional group, that is C double bond O NH, that is amide functional group formed in the case of nylon 6,6. This is the structure of nylon 6,6. Here two are NH2O molecules are eliminated. Here the byproducts are water molecules. The monomers are the adipic acid and hexamethylene diamine. These are the two monomers will undergo condensation polymerization at high temperature and pressure. It will form nylon 6,6. The monomers contain carboxylic acid and amine functional groups. After condensation, this forms the new functional group, amide functional group. This is the example for thermoplastic. What are the examples for thermoplastic? 1. Polyvinyl chloride and its synthesis properties uses are over. Now we have seen the synthesis of the nylon 6,6. Nylon 6,6 is example for the thermoplastic. Okay. What are the monomers? The adipic acid and hexamethylene diamine. These are the monomers. The adipic acid contain one functional group, carboxylic acid, and hexamethylene diamine contain amine functional group. These two monomers will undergo condensation polymerization at high temperature and pressure. It forms the nylon 6,6 with a new functional group, amide functional group. The byproduct is water. See here the properties of nylon 6,6. See the properties of nylon 6,6. See, nylons are translucent, whitish, high melting polymers. The nylons are translucent and whitish color, high melting polymers. High melting point, it contain high melting point. The nylon 6,6 contain high melting point. High mechanical strength. It contain nylon 6,6 contain high mechanical strength. They possess high temperature stability and good abrasion resistance or rubbing or friction. Abrasion means rubbing or friction. Okay. The possess nylon 6,6 possess high temperature stability. In high temperature, it will act as stable. Okay. High temperature, it will act as stable. That's why that possess high temperature stability and good abrasion resistance. Okay, the nylon 6,6 contain good abrasion resistance. They are insoluble in common organic solvents and soluble in phenols and formic acid. They are generally, these nylon 6,6 is insoluble in common organic solvents, but these are soluble in phenols and formic acid. The nylon 6,6 is soluble in formic acid and phenols. Good electrical insulating properties. The nylon 6,6 contain good electrical insulating properties. Okay, electrically these are acts as insulators. Okay, no resistance to UV rays. Okay, the nylon 6,6 does not contain UV resistance. So if you send UV on nylon 6,6, the nylon 6,6 undergo disintegration or degradation takes place. Okay, lightweight, sometimes used in application of place of metals. These are light in weight. Okay, instead of metal we can use the nylon 6,6 in some application. In some application, instead of metal we can use nylon 6,6, and they contain lightweight. Does not absorb water. Nylon 6,6 does not absorb water and dries quickly. The nylon 6,6 dries very quickly. These are the properties of the nylon 6,6. What are the properties? See, nylon 6 are translucent, whitish, and high melting point polymers, and these are having high mechanical strength. They possess high temperature stability and good abrasion resistance, and they are insoluble in common organic solvent but soluble in phenols and formic acid. These are good electrical insulating properties. These are having no resistance to the UV rays and lightweight. Sometimes we can use nylon 6,6 polymers instead of metals. Okay, and does not absorb water. Nylon 6,6 does not absorb any water molecules, and it dries very quickly. Okay, we have seen the synthesis and properties of the nylon 6,6. In synthesis, how we can synthesize nylon 6,6? Nylon 6,6 is prepared by using adipic acid and hexamethyl diamine at high temperature and pressure. These two undergo condensation polymerization. The water molecules elimination takes place and form the new polymer, that is nylon 6,6. Okay, this is example for thermoplastic polymer. These are the properties for the nylon 6,6. See, uses of nylon 6,6. Nylons are used for making filaments for ropes, bristles for toothbrushes, and films, etc. Nylon 6,6 used for making filaments for ropes. We can prepare filaments for ropes by using nylon 6,6, and bristles for toothbrushes and films, etc. Nylon 6,6 used for which is used in making socks, dresses, carpet, etc. By using nylon 6, we can prepare socks, dresses, and carpets by using nylon 6,6. It is used for making seeds. By using nylon 6,6, we can prepare seeds. It also can be used for surgical items. By using nylon 6,6, we can prepare surgical items. And to prepare textile fabrics, by using nylon 6,6, we can prepare textile fabrics. These are the applications of the nylon 6,6. In this video, we have seen the preparation of polyvinyl chloride and applications and properties. And next to example, nylon 6,6 is other example for thermoplastics. Its preparation, properties, and uses of the nylon 6,6 we have seen in this video. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.